Hello guys, welcome to the Science Paper 2 revision. This is revision number 2, and in this video I'm going to explain the answers to this question to show you how you should have answered them for those who tried to answer in the group and failed to answer them. And this video is just aimed at showing you how you should have answered them. So this question came from a 2010 paper. And then this was question A2. The question read like, below are some processes which are used in a laboratory, industry, and at home. Below are some processes which are used in a laboratory, industry, and at home. So we have crystallization, distillation, filtration, neutralization, combustion, esterification, galvanizing, and polymerization. So these are processes in chemistry. Now, let's see the question. A, which one of the processes listed above can be used to separate the following from a sample of seawater? So of these processes listed here, which one can be used to separate the following from a sample of seawater? So seawater is just water that has been picked from the sea. So it is called sea water, water picked from the sea. So how can you separate salt from this seawater? Number one, when we are looking at this question, first of all, we must understand where it is coming from. It is coming from a topic known as separation techniques in chemistry. So if you are unable to identify the topic from which the question is coming from, it is actually hard for you to answer the question, in my view. So the first thing before answering the question, you must be able at least to know the topic from which the question is coming from. So separation techniques, that's where it is coming from. So separation techniques, under separation techniques, we talk of ways in which we separate mixtures. Okay, so separation techniques is about talking about ways which we use to separate mixtures. And on this list, we have some of the ways which are used to separate mixtures. Now, before you understand the separation of mixtures, you must actually understand what actually makes it possible for mixtures to be separated. Why is it possible that mixtures can be separated? Number one, you must understand that mixtures or components in mixtures retain their own properties. So what enables mixtures to be separated is that the component in the mixture retain their properties. What properties are these? Number one, it could be solubility, is one of the properties they retain or maintain. Then number two, it could be boiling and melting points. I've talked of solubility, then it could be boiling and the melting point. Okay. Then another property that they can maintain is their density, and another property which they can maintain should be magnetism. Okay, so these are some of the few properties which components in the mixture maintain, which enables them to be separated. Okay, so for instance, we are talking of separating salt from seawater. So salt is a substance which dissolves completely in water, and therefore it is not possible to see it. And therefore, among these processes given here, the one which qualifies to be used to separate salt from seawater is crystallization. Okay, so that one will be crystallization. Why? Because salt maintain its boiling or melting point. So salt and water have got different boiling points. So crystallization just involves evaporating the water so that you remain with the crystals of water, I mean salt. So crystallization. Then how can you separate water from seawater? So you know seawater again is a mixture. So it has a mixture of a lot of components like we are seeing salt. It can have also solid particles that are dissolved in there, different types of ions dissolved in there. So how can you extract or separate water alone? So of all the methods provided here, you can use distillation. Distillation, which is the process which involves um, evaporating the water and cooling it later. So it involves evaporating and then condensing the vapor back into the water in a Liebig condenser. Then the method that can be used to separate sand from seawater, because sand does not dissolve, it is an insoluble substance. So the method that we usually use to separate insoluble substances from the solution is filtration. So here it is filtration. Okay. Then we move on to the next question. The next question, which is A, again they made a mistake. This was A, this was supposed to be B. They're saying state the process from the list of processes above that can be used to Roman numeral 1, manufacture plastics for making buckets. So here the process which is used to manufacture plastics for making buckets is polymerization. This one here, polymerization. Okay. So this polymerization actually we don't talk about under separation techniques. So it is actually a mixture of things they did here. So polymerization is talked about under organic chemistry, under polymers. So polymerization is the process by which monomers are joined together to form polymers. You join small units of especially alkenes to form longer units called polymers. Okay, so that is what polymerization is, the joining of smaller units called monomers to form larger molecules called polymers. Then they're saying produce carbon dioxide from carbon. For you to produce carbon dioxide from carbon, carbon must undergo combustion. It must burn in oxygen. So the process here is actually combustion. Okay, so in our answering, we can say combustion. Okay, which is the process of burning something in oxygen. Then we move on to question 2. Question 3, A3. A3 says an element has an isotope with the nucleon number of 7. So we have an element has an isotope with nucleon number of 7 there. Then they're saying each neutral atom of this isotope has 3 electrons and a nucleus containing 2 different types of particles. So what have we gathered here? In this statement itself, we have gathered that we have an isotope. Okay? We have an isotope, and then we need to understand what isotopes are. Then this isotope that we have, it has nucleon number. Nucleon number is the same as the mass number, which is represented by A, capital A sometimes, which is equal to 7. Then other than that, we are told that each neutral atom of this isotope, the keyword is each neutral atom of this isotope has 3 3 electrons. So we know, okay, number of electrons is equal to 3. Okay, and a nucleus containing 2 different types of particles. Okay, we have a nucleus, and in that nucleus there are 2 different of types of particles. So in the nucleus, what different particles are there? So let's just identify them. So the nucleus has which types of particles in it? It has 1, protons, and 2, it has electrons. Okay? No. Why am I saying electrons? Protons and neutrons. So these are the particles found in the nucleus of an atom. Other than that, since we are revising, you must also know that around the nucleus are shells, and what you find in shells are electrons. So electrons are found in shells or orbitals. So electrons are found in what? In shells. I want to make this one at least known for you. So now, okay, we understand this information there as it is. So let's see how this information is going to help us answer this question. Then they're saying, A Roman numeral 1, give the names of these particles and the number of each particle present in each nucleus. So they're saying, oh, we give the names of the particles that are found in the nucleus and the number of each particle present in each nucleus. So in a nucleus, we have seen that there will be protons, and also there will be neutrons. Now they want us also in here to state the number of particles. Like if it is protons, how many are there in these in the nucleus of these isotopes? So what we are going to do for us to know how many protons are there, it is to use this information here. We must understand that the number of electrons is equal to the number of protons in a neutral atom here, each neutral atom. So in a neutral atom, the number of protons and electrons are equal. So it means that protons are also 3. So we can put 3 here. How about neutrons? We must know that neutrons are found in the nucleus. So neutrons, when you add neutrons and protons, you find what we call the nucleon number or mass number. So nucleon number, or it's also known as mass number, is a combination. So nucleon number, which is mass number A, is a combination of protons plus neutrons. Now, if we are told that nucleon number is 7, and we have identified that the proton number is 3 plus neutron, how can we know the number of neutrons? By just collecting like terms. So this 3 can cross here so that it becomes like, let me solve from here, it becomes like 7 minus 3 is equal to neutron number. So 7 minus 3 is 4, which is n number of neutrons. So number of neutrons here will be 4. Okay? So this is how we are supposed to be able to dissect the information here. Then we move on where it continues to say on Roman numeral 3, compare the masses and the electrical charges of these particles. Compare the masses. We compare the masses and electrical charges of these particles. So in terms of masses, we answer here. We are going to say that we will consider these as their masses. So say neutrons are more massive than what? Than protons. Then in terms of charge, let's answer from the next. Charge, they provided the space. Okay. In terms of charge, you should know that protons are positively charged. The wanted charge are positively charged. While neutrons are negatively charged. Okay, then we come to B. They're saying, what is the difference in the nuclei of this isotope and its isotope whose nucleon number is 6? Okay, the way the statement they are put here, they don't make very much sense. As if this isotope has another isotope. It's supposed to be, what is the difference in the nuclei of this isotope with this another isotope, maybe whose nucleon number is that, not and its isotope. Anyway, what is the difference in the nuclei of this isotope and its isotope whose nucleon number is 6? So we have one isotope. Let's say we have isotope A, which had a nucleon number of 7, mass number. And then we have also isotope B with a nucleon number of 6. So both, they were said to have same number of electrons, 3. So those number of electrons, there will be atomic number, which we can put here. So you have seen. So now, what is the difference here? So the difference is that the number of neutrons. In this one, if we say 7 minus 3, the number of neutron is 4. This one, if we say 6 minus 3, the number of neutron is 3. So if they say, what is the difference in the nuclei of this isotope and its isotope whose nucleon number is 6, we are going to say they differ in the number of neutrons. So they differ in the number of we'll say neutrons. One has 3, while the other has 4. Okay, then we move on to the next question. Use the information in the table to answer the following questions. So we have the information in this table. So let's study the table. This question came from 2011. We have substance, which is sodium. Okay, we have substance, conducts electricity when solid, melting point degrees Celsius, dissolves in water. So like sodium is a substance, sodium chloride. In terms of conducting electricity, does it? They said no. Melting point, they said 808. Dissolves in water, they said yes. We come to sulfur, conducts electricity when solid, no. Melting point 111, 13 degrees Celsius. Dissolves in water, no. We come to tungsten, conducts electricity when solid, yes. Melting point 3377. Dissolves in water, no. We come to wax. Conducts electricity in solid? No. Melting point 35 to 50. Dissolves in water? No. We come to aluminium. Conducts electricity? Yes. Melting point 660 degrees Celsius. Dissolves in water? No. Then they said, name one metal from the table. So from these listed here, one metal which is a metal here is actually either aluminium. Aluminium is a metal, or we can talk of tungsten. Okay. Then they say here Roman numeral 2 is supposed to be how can you tell from the table that the substance you have chosen in A is a metal? So like, how can we tell from the table that aluminium or tungsten is a metal? So here again, the question is coming from especially a combination of properties of substances. Okay, so here, what enables us to know that from the table, what can enable us to know from the table that aluminium or tungsten are metals is conductivity of electricity, because metals conduct electricity. So you can say, because metals conduct electricity. Just put like that, it will be fine. Then we come to B. How can you tell from the table that wax is a mixture? So here is wax, and they're saying it is a mixture. Now from the table, how can we tell that wax is a mixture? First of all, these guys are trying to test you the understanding of the behavior of mixtures. Mixtures have got what we call a variable melting point or boiling point. That is one of the characteristics of mixtures. Mixtures do not have a fixed or sharp melting or boiling point. They have a variable. Like when you look at wax here, in terms of melting point, it has 35 to 50. So this is a variable melting point. So it starts melting at 35 up to 50. If it was pure one, not a mixture, it will have one melting point, just one value. Like water melts at 0 degrees Celsius, that is a fixed number, 1. If it has 2, it's a range. So you can say, when they say, how can you tell from the table that wax is a mixture? You can say, because it has, you can say, variable melting point. Okay, then we move on to C1. C1, they're saying, name a compound from the table. So from the table, which one is a compound actually? Sodium chloride. Sodium chloride is a compound. So you can say sodium chloride. Why? Because it consists of two elements. There's an element sodium and then there's an element chlorine put together or combined together. Then they said, explain the meaning of the word compound. So the word compound means something consisting of two or more atoms of elements chemically combined. So in explaining a compound, you can say a compound is a combination. In fact, the best way you can say is a chemical combination, is a chemical combination of two atoms of elements. So that's what a compound is. Okay, so compounds usually they are formed when there is chemical combination where one atom and another atom combine so that they form a new substance. This new substance which is formed has got different properties from the individual atoms of elements it is formed from. And usually during formation of compounds, bonding is involved and the energy is involved. More energy is used up and some more energy is given out. Okay, so let's move to the next question. Next question was question 2 from the same year. It's saying 2, use the list of separation techniques below to answer the questions that follow. They're saying fractional distillation, simple distillation, use of separating funnel, magnetism, chromatograph, evaporation, and filtration. So these are the separation techniques here. Then they're saying choose one method from the list above which can be used to separate A, sand from water. What can we use to separate sand from water? You know, sand does not dissolve in water. It is insoluble. So the best method we use for separating it is filtration. So you say filtration. Then we come to oil from water. How do you separate oil from water? You know, oil and water do not mix. Do not mix. So these are immiscible. They don't mix with each other. If you get oil and water, put them together, they will never mix. There will be a separation. Oil will be alone, water will be alone. And one of the methods that we use to separate such a mixture of immiscible liquids is separating funnel. So here you say separating funnel. Then water from ink. So how can we separate water from ink? Usually this one we can use chromatography. So chromatography works with solubilities as well. So it is suitable for substances that dissolve but they have different solubilities. Then is sulfur powder from iron filings. So sulfur is a nanometal, iron filings are metals. So metals, some metals like iron are magnetic. So they can be attracted by magnet, but sulfur is a nanometal, it cannot be attracted. So the method to use is this one here, magnetism. Then salt from paraffin. So salt does not dissolve in paraffin. Okay, salt does not dissolve in paraffin. So the method that we can use here is also filtration. So we move on to the next question, which came in 2012. It says two miscible liquids. Two miscible liquids with boiling points. Okay, so we will end here because the battery for my laptop, it has shown me that it is now finished. You can see, so it is I'm remaining with 19%, which is 39 minutes. So let me answer this question, and then the rest of the question will be answered in another video. So we are saying two miscible liquids with boiling points, one 78 degrees Celsius, another 100 degrees Celsius, were accidentally mixed. So you must understand what are miscible liquids. Miscible liquids are liquids that mix uniformly, like water and alcohol, or water and ethanol. These can mix with each other uniformly. So when these mix uniformly, they are saying, A, name the process which can be used to separate the mixture. It is fractional distillation. Fractional distillation. Then B, they are saying, draw a labeled diagram showing the arrangement of the apparatus used to separate the mixture. So this one, they had to put 3 marks. For me, this one was involving, they were supposed to put like 6 marks. Yes. Because drawing would consume a lot of time, which means that for someone to finish drawing, at least must gain a lot of marks. So this one requires you to have just a fractionating column like that. Then you can even have a round bottomed flask or flat bottomed flask like that. Okay. So this one actually must be fixed by a rubber. There must be a rubber band here. Okay. Then here, you must have again some water will go in, some water will go out. So here again there must be something like a rubber. Then here must have a stand, tripod stand, and this source of heat here. So those are glass beads. Then you can say hot water in, cold water in, hot water out. Then here you can put anything like a beaker on a stand, also collecting something. So this one is a Liebig condenser. You label them. Then this one is a fractionating column. Then this one, it can just be a flask. Yeah, then these are enough just like that for 3 marks. But in my view, looking at the time to be involved in for someone to draw it, it must require more marks, not 3. Then we move on to this question which says, explain how you can obtain hydrated sodium sulfate crystals from an aqueous solution of sodium sulfate. So explain how you can obtain hydrated sulfate crystals from an aqueous solution of sodium sulfate. Here they repeated a lot. This statement is on crystallization. So they repeated a lot. When you say sodium sulfate crystals, don't put hydrated. And when you say from an aqueous solution, okay, so okay, an aqueous solution. Yeah. So how can you obtain sodium sulfate crystals from an aqueous solution of sodium sulfate? So crystals are formed when water of crystallization is not driven completely from a salt. So how do you ensure that water is not driven? So what you do is you evaporate the aqueous solution of sodium sulfate to saturation and allow and crystallize it. Yeah. So you can say evaporate aqueous solution of sodium sulfate and crystallize it. Okay, so you crystallize it. How? You evaporate to saturation point and then allow the remaining mixture or solution to cool down naturally or under normal temperature. So let's see how many minutes we are remaining with. 15. Okay, let's see if we can push in one more question. Okay, so this question we will push it later. We will push it later, looking at the time remaining. For now, bye guys, and see you in the next